All right, we're recording. So if you're watching this, just know it's a re-recording after the original URC Sustainability Symposium presentations. There was a technical issue. But since then, I have also presented at the URC Interdisciplinary Science and Engineering Symposium, where I tied for first place. So my name is Connor Melican. I'm a senior here at UNH, and I'm majoring in earth science with a concentration in climate. And for my senior project, I wanted to look into a local issue and find a way to benefit the community. So I focused on surficial warming, which I present here as an analysis of urban heat flux in Durham, New Hampshire. So surficial warming is amplified by urban heat island effect. And this occurs within the abundance of building materials in an urban setting, such as roads, parking lots, roofs, and other large infrastructure. And the heat trapped here over time is released slowly back into the air over diurnal timescales. But in contrast, in rural settings like a countryside or woodlands, the heat is released much faster on those same diurnal timescales. So I set up a study area of 45 sites and I sampled them daily throughout August and September of 2020. They had varying land covers, and the data I collected at each was solar radiation, surface albedo, and surface temperature. And then I also used online data sets for other meteorological information. I wrote MATLAB codes to process my data from Excel files and then used the Monino-Bykov similarity theory to approximate physical conditions both at the surface of these sites and then by height above ground. So to focus in on panel 3 of figure 1, this is just an example of the MATLAB generated wind and temperature profiles. This one's for August 7th at Hannaford's parking lot. And it shows that the surface temperature was about 120 degrees Fahrenheit with 5-mile-an-hour winds. And then just 5 feet above the ground, which is about the average height of a person, the air temp is about 97 degrees Fahrenheit, while the reported air temp for that day was 82 degrees Fahrenheit. So you can see a significant temperature difference here, which people could be exposed to. And then moving on, figures A through C, these are all various diurnal progressions of insolation at 3 different land cover types. Figure A being asphalt, B is concrete, and C is grass. And the air and surface temperature at the grass site reached equilibrium far sooner than that of both pavement sites. And this is indicative of the urban heat island effect. So just to wrap up here, this project, it should be repeated in the near future to continually assess the UHI trouble spots here locally. And then also for any upcoming developments of the town or the campus, they need to consider the following to help reduce surficial warming. This can be done by using less pavement overall, don't cluster pavements, and then among pavement sites, you can implement energy harnessing technologies. For buildings, you can use roof cooling paints, and then just in general, maximize green spaces while diversifying the greenery for better drought resistance. And then also, you can implement smart buildings through means of automatic thermostats and such. So that's my presentation, and thank you for watching.